very good morning, one and all. I, Dr. Gayatri Ambadkar, the convener of this conference, on behalf of Nutan Maharashtra Institute of Engineering and Technology, and on my personal behalf, extend to you a very warm and cordial welcome on second day of International Conference, Advances in Engineering, Technology, and Business Management. This is the second day. The morning session, we are starting with the keynote speech of a very eminent person. I welcome Dr. SESHADRI Mohan for today's keynote speech. And I also welcome some of Sir's colleagues who are about to present in this conference. So I welcome Mrs. Sita Lakshmi, Mr. Raghu Raghavan, Mr. Selvakumar Murlidharan, and Mr. P. Parameshwaran. So welcome you all once again. It's my privilege to introduce to you all our today's keynote speaker, Dr. SESHADRI Mohan. Dr. SESHADRI Mohan is currently a professor in System Engineering Department at University of Arkansas as Little Rock. From August 2004 to June 2013, here he served as the chair of Department of System Engineering. Prior to this current position, he served as Chief Technology Officer and Acting CEO of IP Servonics, where he consulted for several telecommunication firms and venture firms and served as CTO of Telesima. Beside this position, his industry experience spans a decade at New Jersey-based Telecordia and Bell Laboratories. Prior to joining Telecordia, he was an associate professor at Carlson and Wayne State Universities. Dr. Mohan has authored and co-authored over 150 publications in the form of books, patent, and papers in referred journals and conference proceedings, with 6,400 citations to his publication. He has co-authored the textbook Source and Channel Coding and Algorithmic Approach published by Springer. He has contributed to several books, including Mobile Communication Handbook, the Communication Handbook, both from CRC Press. He holds 15 patents in the area of wireless location management and authentication strategies, enhanced services for wireless and connected vehicle. He has received SAIC Publication Prize for Information and Communication Technology. He has served and is serving on the editorial boards of IEEE Personal Communication, IEEE Surveys, IEEE Communication Magazine, Journal of Mobility and Cybersecurity, and Wireless Personal Communication by Springer. He has chaired sessions in many international conferences and workshops. He has also served as a guest editor for several issues of IEEE Network, IEEE Communication Magazine, and ACM Monet. He served as a co-guest editor for several featured topics of IEEE Communication Magazine, Human Bond Communication in February 2019, Social Network Meet Next Generation Mobile Multimedia Internet, October 2015, Convergence and Application Services in Next Generation Network, March 2012, and Social Network Meet Wireless Network in June 2012. In April 2011, he was awarded with 2010 IEEE Region 5 Outstanding Engineering Educator Award. He has received the Best Paper Award for his paper, A Multipath Routing Scheme for GMPLS Controlled WDM Networks, presented at the 4th IEEE Advanced and Telecommunications System Conference. Dr. Mohan is co-author of Startup Intel Nexus LLC, the objective of which was the development of innovative connected vehicles architecture and applications to improve traffic safety and reduce accident and congestion. Dr. Mohan holds a PhD degree in electrical from MC Master University, Canada, the Master degree in Electrical Engineering from Indian Institute of Technology, Kanpur, India, and the Bachelor degree in Electronics and Telecommunication from University of Madras in India. It's really our honor that such an eminent personality is present with us today to deliver a keynote speech. Sir, I'm really thankful to you for accepting our invitation and being present with us, even it's late night at your place. Thank you so much. And now I request you to start with your session.
Thank you. Thank you for the invitation. Thanks to Dr. Janavi Inamdar and Dr. Gayatri Ambedkar for inviting me to deliver this keynote speech. I'm delighted to be present here. Let me share the screen and show the title of my talk. As you can see, the title of the talk is Artificial Intelligence and Machine Learning Enabled Connected Vehicles. Well, thanks for the really generous introduction. And I don't need to mention much more about myself. But one thing I may want to just mention is that you see here the Wireless World Research Forum, as well as University of Arkansas at Little Rock. The reason Wireless World Research Forum is mentioned is because of the fact I'm also the chair of the Connected Vehicles Working Group of WWRF. I am delighted to be here, and I want to talk about the area of connected vehicles propelled by the era of explosive growth of multimedia applications and services. We are all witnessing the onset of autonomous vehicular technology, and the demands on spectrum resources. You see auctions for new spectrum for 5G and going forward beyond 5G to 6G and so forth, and exploiting the spectrum and managing the spectrum in smart and efficient ways. And autonomous vehicles or connected vehicles will definitely need such smart spectrum management. And we want to make sure that communication establishment among autonomous vehicles is sustained for a long period of time with very little delay. It does pose a formidable challenge, and what we are going to do is look at where the standards are going, what the technologies are that enable connected vehicles, and what the future holds for us. This talk is only to give you a glimpse of what is out there and not provide an exhaustive list of all the developments going on in the field. And in the process, we hope to introduce some of the research work that we are conducting and some of the activities that we are carrying out in terms of sponsoring students from India and offering research opportunities to them and conducting research on the premises of University of Arkansas at Little Rock campus. So what we are witnessing is that the traffic system could become congested, and the traffic navigation could be quite limited in remote places and where there are terrains and foliages. There could be loss of cellular coverage, and that could cause congestion or loss of connectivity to the rest of the world, to the cellular world. The traffic congestions alone cost US drivers about $300 billion in 2016, and is easily projected to be almost $1 trillion in the years going forward. And the drivers also spend a considerable amount of time during peak hours in congested traffic. 42 hours a year. I think it's on the optimistic side. In congested cities, you can probably you spend much more time than that in cities like India, Bangalore, New Delhi, and so forth. Now, it's not just the congestion that is the problem. That's besides congestion, there are traffic accidents. Just in 2010 alone, the accidents cost the drivers, the economy, the insurance companies, and about $871 billion. And all of these are available in US Department of Transportation reports compiled in May 2015. It's not just the loss of resources, money, but human resources here. 33,000 deaths, and probably more as the traffic congestions increase, and injured in the millions, and millions, tens of millions of vehicles damaged. And if you add a 20% increase in cost over that in 2000, in 2020 we can estimate the cost to be about $1 trillion, and that's a substantial amount of loss, and loss to the human beings, to the economy, and see what we can do about all this. What is connected vehicles going to do, right? The field of connected vehicles, you can visualize that as standing at the confluence of multiple disciplines. I'm just quoting 3 of them, but a number of the other fields also contribute to this. So the wireless technology, cellular technology, and the evolving standards, 5G and beyond, they definitely help in the area of connected vehicles. Internet of Things, and growing from into 50 billions as of today. AI and machine learning evolution and the impact that they have on connected vehicles, new services, innovative technologies, and innovations in services as well. So the vision, the 5G and 6G are enablers here, and you can see here the multifaceted response and impact of 5G on data rates, spectral efficiency, mobility entertained up to 500 kilometers per hour, and latency, and connection density, number of devices per kilometer square, network energy efficiency, and area traffic capacity, that is megabits per second per meter squared, and the peak data rate. See, these are the multifaceted performance requirements of 5G, and you can see that that over LTE, right? The spectral, the requirements, the performance requirements are orders of magnitude more compared to that of in 5G as opposed to 4G LTE. And here there is, for another comparison here between 5G and 6G vision. If you can, here LTE um, occupies this area, and 5G, the outer sphere, the multidimensional sphere here. So here, 5G and 6G compared. The performance of 6G, as you can see, even orders of magnitude more compared to that of 5G. So these are technological evolutions taking place that are going to enable the field of connected vehicles and autonomous vehicles going forward. And I mentioned AI, and AI does come to help in enabling autonomous vehicles and providing end-to-end AI composed of local AI at the user equipment and AI at the over the radio link, right? And then the core network is another place where AI can be offered. And then applications, enabling applications to be AI smart, machine language enabled and intelligent. And then from user equipment to the core network, you can think of the local AIs as providing a joint AI, and similarly within the core network and towards the application server, and then the end-to-end AI. So the entire AI field can encompass end-to-end from user devices to the applications and provide new innovative services. And this vision is from the Samsung 6G white paper, vision paper. So we talked about AI over the air interface, and you can think of AI and channel modeling, data collection and extraction, okay, of data as vehicles pass through traffic. They encounter various environmental parameters which are measured, and then such as the angle of arrival and delay and so forth. So those are kind of parameters that are measured on a continuous basis and provided to the cloud for data processing, or to the processing by the vehicle itself in its computing mechanism. And modeling and evaluation. See, the channel models, channel is stochastically varying, and the instant to instant, it is dynamic. And to reconstruct the channel from these parameters, from the parameters that are measured, and to reconstruct the channel and provide for accurate reception of signals. So all of those could be AI enabled. And more elaboration of this. For example, here, as you can see that the environment from one end of the vehicle, as the vehicle progresses from one end to the other in this direction, changes. And here you have reflecting surfaces. There are reflections taking place, multi-path propagation, and then the trees, tall buildings could provide for interruption of radio signals and multi-path propagation. So those are aspects that require estimation and modeling. So the vehicular network, AI-enabled vehicular network. So in this context, you can establish vehicular network. There are protocols available: cellular V2X, DSRC, and we have ourselves used DSRC to connect vehicles and tested it on the road. So you can create vehicular networks and enable communications between them. So I'll talk somewhat more about this, and you can think of the physical resources, the control layer controlling, and the measuring and providing reinforcement learning or AI machine learning mechanisms to extract data, to learn from data, and provide useful information to the vehicles um, that are traveling nearby. So certainly, cloud and storage and all of these are going to be helpful. The physical resources are going to be helpful in enabling the connected vehicular networks. I already mentioned about the mobile evolution in IoT and mobile data traffic. So here is the set of standards. The set of standards, the other dimension that I talked about are standards evolution. We talked about wireless technology, and then now the standards evolution could be from industry consortia efforts, as well as from standardization bodies such as 3GPP, ITU, IEEE, and so forth. So here, the Society of Automobile Engineers, SAE, developed levels of automation from level 0, no automation, to level 5, automation. So the full, complete automation. So in level 0, you start with eyes on and hands-on technology. And then you provide other kinds of things such as cruise control, etc. And then more and more features, okay? So more and more examples of features are adaptive cruise control, lane centering, and lane crossing signals, and so forth. So those are kind of new features that could be introduced, that are introduced at SAE level 2. And then level 3 and level 4 and level 5, these are increasing levels of automation. So there is still eyes on, hands on here, but you can do some relaxations. For example, traffic jam chauffeur here, automated parking and parallel parking and so forth. In level 4, eyes off and hands off. However, this situation doesn't necessarily ensure total autonomous vehicular operation, but under extreme conditions, environmental conditions, you may have to have eyes on and hands on in this technology. So in SAE level 5, even under extreme weather conditions, it is totally autonomous. So it's almost the same as level 4, but with the added feature of independence from environmental impacts. So that is SAE level 5. So you can see that the industry consortia is also moving in those directions, in the direction of enabling connected and autonomous vehicles. So the development in technology is also evolving to provide you with technologies where there's autonomous features, or the evolution towards autonomous functions are enabled. So this shown here is this Uber vehicle, an Uber vehicle with 360 degree radar coverage, top-mounted radar. It provides three-dimensional scan and 360-degree environmental measurement. So there are both forward-facing cameras and backward-facing, rear-facing cameras, side and rear-facing cameras. So and then the braking systems, automatic and emergency braking systems. the vehicular platform, modified vehicular platform, provides for all of the controls and so forth, cooling, the interior, the ways to enable all the electrical functions and so forth. So the gate, and then there is a gateway module provides a platform for the self-driving system. Then there is a computing and storage unit that allows for all the computations, then GPS positioning, and so forth. So it's a considerable amount of automation is enabled in this technology. Please let me know when I should stop, if you can give me some indication as to the time limit 5 minutes before I can try to speed up. So this is the evolution in the cellular V to X technology, V to anything, V to everything. In the so the V to X release 14, 3GPP release 14, 3GPP release 15, and release 16, they all address V to X and 5G V to X. And here the phase 1 in phase 2 and phase 3 of evolution of connected vehicles. Basically, in the initial use, in the initial release, there were only the basic uses of the autonomous vehicle features, such as safety, basic safety measures. And then new use cases were introduced in in LTE and also in 5G. In 5G based system, it provides increasing types of services, innovative services, including platoons of vehicles and so forth. So I'll try to skip this, and we already talked about a number of automotive safety features, such as emergency brakes, and do not pass warning, lane crossing, and all that. And then that coordinated driving, very high speed coordinated driving of vehicles, real-time local traffic conditions updates. So all of these are kind of other complementary use cases that were introduced in the evolution of connected vehicles and use cases of LTE V2X and 5G V2X. And then in the applications domain, we can visualize a number of applications are portrayed here. I won't go through the whole entire range of applications here, such as fleet management, toll collection, trip planning, travel assistance, and intermodal communication as you traverse from land to sea to air and so forth. So and then vehicle to vehicle communications. V2X includes all of this: V to infrastructure, V to vehicle, infrastructure to vehicle, as well as vehicle to pedestrians. And the safety of pedestrians is very important. You would have probably read about Tesla autonomous vehicle, or the Uber autonomous vehicle running over pedestrians and causing damages. So those are kinds of the accidents that could be avoided with careful planning, with smart applications. Smart applications could be personal assistant, holographic avatars, all these augmented realities and virtual realities and hybrid realities, smart valet, smart taxi, driver drowsiness detection, virtual presence, and multisensory based applications. So AI-enabled the personal assistant. I mentioned that as one of the applications. So let's take a look at what it would look like, what it would be like.
But I could demonstrate all of the features of autonomous mode. For example, I could bring up your Netflix queue so you can continue binge watching Game of Thrones from earlier when you skipped speech rehearsal.
We were going to keep that between us, right? Let's skip that.
I can also plan for your arrival back here.
My arrival back here?
Yes. After the demonstration, I can reserve parking at the nearest charging station, so I'll be fully charged after your speech.
That does sound tempting, but...
And since my records show that I'm overdue for servicing, on the way back, I can stop by the nearest Nissan service center and confirm they'll have the parts we need in stock.
I get it now.
Okay, so you get an idea of the kind of a personal assistant that you can envision, or you will be provided with, and that can make life somewhat comfortable or uncomfortable. So, and then driving with augmented reality. And all right, let me skip this. The classification of ML and so forth. There is another area that is becoming a field of research currently. The field of reconfigurable intelligent surfaces. So reconfigurable intelligent surfaces don't necessarily have to obey the known laws that we have seen. By configuring them intelligently, you can actually make them obey different types of rules. For example, the angle of incident and angle of reflection don't necessarily have to be equal. So depending upon the environment, the tall buildings, terrain, mountainous terrain, for example, and foliages, you can introduce intelligent surfaces that can reflect the beam satisfactorily and provide adaptively, actually, these is programmable, and thereby enable the vehicles to receive the radio signal in a more efficient manner, spectrally efficient manner. A number of use cases and applications exist. I won't go over each one of them, but quite a variety of them I've already talked about. V2I safety, environment including data gathering, high speed and mobility, smart roadside assistance, and the environmental effects, and a number of agency-related data, and vehicle-to-vehicle safety because they are connected. And quite a few of the applications are detailed here, listed here, and they can all be quite interesting. So here is what we can expect.
Let me introduce
from
you to what we call
CV2X.
Cellular Vehicle to Everything, or CV2X. It's this family of technologies that allow vehicles to really connect with their surroundings. Your car becomes a moving data center that can share the information captured by its sensors with the entire transport ecosystem, making it safer and more efficient. The beauty of CV2X is that your car can basically talk to another car by sending a quick message through what we call direct short-range communication. This works even when there's no network. All right, let me give you an example. So, imagine you're about to make a left turn, but a speeding car is incoming in your blind spot. Your car will anticipate and alert you in real time, avoiding a potential crash. And it doesn't even stop there, because that's when the long-range communication mode comes in, sending messages via the cellular network It can relay information to even more distant cars, creating a whole transport ecosystem that's safer and intelligent. A traffic jam 2 kilometers ahead, your car will know and plan its journey long before you could. And what's great is that it's not only cars that can receive the message. It's transport infrastructure, it's pedestrians and cyclists through their mobile devices. Can you imagine?
So that gives you an idea of what CV2X can do. It can do a lot more, and then there are many more advanced use cases of the introduced by 5G and navigation systems, route prediction, AI algorithms for autonomous and connected vehicle navigation, and basically efficient traveling and reduction in commute time. This is part of some of the things that we were experimenting with at University of Arkansas at Little Rock, and this is on intelligent traffic navigation. So this is a short video of what could happen under traffic congestion.
Sarah, Ben, and Bob live in different locations in West Little Rock, and all of them must travel to their jobs in downtown Little Rock every weekday. They each get off at 5 p.m. and notice there is a traffic jam due to an incident on Interstate 630. Using a traditional GPS, they are each rerouted to the same route. This could cause new traffic jams and a frustrating end to the workday. Instead, they use the advanced optimization algorithm of trims, and they are all rerouted to different routes, creating an optimized distribution of traffic. They all arrive home quickly and enjoy a glass of wine.
So we could put AI and ML towards intelligent navigation, and then more advanced applications such as detecting drowsiness in drivers, and including erratic behaviors of drivers, alert drivers of connected cars when such conditions are noted, and also alert the drivers so that those that are nearby can take possible corrective actions to avoid accidents. So the drowsiness, the students, these are students from India and one of my PhD students. They implemented AI machine learning systems to detect the drowsiness in drivers, basically extraction of features, eye movement and movement of the mouth, such as yawning and so forth, and frequent position shifting of the position, the phase, and so forth. So those were some of the features that were extracted, and an experiment was performed to ensure that it worked. Here is the result from such an exam test. So when the eye kind of the aperture ratio kind of narrows down, then it's called a per clause measurement. But the idea is that when the eyes narrow down, the detection of that feature enables the alarm to be set and alerted. We also conducted a connected vehicles test where we connected one vehicle to another, and I was actually in one of the vehicles. We drove through interstate here and the I-630, and we tested a driver pretended to be drowsy and alert, and that raised an alarm and alerted all the nearby vehicles. So it was a quite interesting study by actually a couple of undergraduate students from India, actually Vishwanik, and Dr. Janavi Namdar was the coordinator at that time. She facilitated the exchange of students from India to UAE Little Rock, where they conducted this research over a period of six weeks during summertime.
Hello.
Safety, other important applications, safety maneuvers. I'm going to quickly finish this as I think I have exceeded the time. Entertainment.
Yeah.
AI
So you
driven
can continue for 2-3 minutes here.
and then the evolution in 5G and 6G and so forth. All types of hybrid realities and so forth that enable that could make use of AI and provide some innovative applications. So basically what we had covered was dynamic in our research at UALR, dynamic spectrum sharing and leasing of spectrums. And different types of modulation, coding, channel estimation, waveform design, MIMO, massive MIMO. These are types of things that had gone on. Navigation, smart routing, maneuvering, collision avoidance, vehicle platooning. So we haven't carried out a number of other things, but in smart applications such as this detection of drowsiness, so we have done some work. Smart applications, personal assistant and so forth that I already mentioned. Multisensory applications that go beyond touch, visual, and auditory to taste and smell as well. And in the use of AI and ML can be used to increase driver safety. So with I'll quickly finish up. So Wireless World Research Forum is going to conduct a huddle in 2022, actually 10th, 11th, and 12th actually also included, May 12th, 10th, 11th, and 12th May 2022. 12th is going to be the connected vehicles session that I am organizing. And there is also a e-health workshop that precedes on 6th of May, and they're going to take place in Ottawa, Canada. Thank you, and sorry if I had taken more time than allocated. That concludes my talk.
Thank you. Thank you. Thank you, sir. Thank you for this excellent keynote speech. The knowledge shared by you will definitely help all the researchers who are working in the domain of AI and machine learning enabled connected vehicles. And especially some of the topics that you have covered, channel modeling and estimation, that are really useful for the electronics, telecommunication, and computer and information technology students. So it was really amazing speech, and all the latest topics of researcher you have covered. Thank you, sir. Thank you so much for being with us in spite of a very late night at your place. So thank you. Thanks a lot again.